So in this problem, we're given a cubic 4-term polynomial that does not factor using grouping. We are told that we have a solution where when x is -2, we get a result of 0. So the remainder theorem says that x minus 2, x plus 2, I meant to say, is a factor of this polynomial. Because if I had x plus 2 equal to 0, that would have solved to have x equals -2. So this f of -2 equals 0 is a lot of information. It's huge. It allows me to use synthetic division, x equals -2, to produce further factors. So we know x plus 2 is one factor, and now we're going to go ahead and bring down our coefficients to -11, -5, 50 to produce our quadratic factor if x plus 2 is factored or divided out. So we're going to bring down the 2 and then perform synthetic division by multiplication with that number in the box and then putting the results underneath the next coefficient. So that should give us a -4, and then you add and get -15 and repeat the process. So now we get -15 times -2, which should give us a +30, and then we add and get 25. And finally, we take our 25 over here, multiply, get -50, and as expected, the result is 0 because we were told the result was 0 over here. The remainder would be 0 because the remainder theorem says if I do synthetic division, then f of -2 will be the remainder here. Anyway, all that to say we've got our quadratic now because we had a cubic divided by a linear. With synthetic division, we know that our first term is going to be a quadratic term, and then we go descending order, x to the 1, and then x to the none. And we can write our factored form. F of x is now factored to be equal to x plus 2 times this 2x squared minus 15x plus 25. And then our job is to set it equal to 0 to find the rest of the factors, the rest of the roots, I meant to say. And to do that, we want to factor further this quadratic. If it didn't factor, we would use the quadratic formula. Let's see what happens. We throw the x over here, do the magic. And remember, you're supposed to multiply your a value times your c value. So this is going to be 2 times 25 up top, which is going to be 50. And -15 is the b value on the bottom. And so our x works. We have magic numbers of 10 and 5 that multiply to be 50 and have a sum of 15. We just have to make it negative to be -15. So my magic numbers are -10 and -15. Now, this problem has an a value, so we don't get to just jump in there and say, oh, it's x minus 10 and then x minus 5. Don't do that, please. If you have an a value, the magic stops with the numbers. The rest of the process must break up the -15 to be a -10x and a -5x to rewrite it so that I can use grouping to finish the process. So this 2x squared comes down, and this 25 comes down, and then we should be able to factor by grouping this quadratic. So we group the first two together and look for a common factor. They have a 2x in common, so you say 2x times the result of the quotient here, which is going to be divide each one by the GCF, 2x, and that should give me a 1x. Divide the -10 by 2x, and that should give me a -5. And now I'm looking from the second to the right-hand side of the problem. I'm looking for a GCF that's going to produce this same x plus 5 binomial. So I look and I see a -5 and a positive 25. They have 5 in common, but I need to force the negative to be in common also. So I'm going to call the GCF -5 and then write the quotient. So I'm going to divide each of these by -5. That's going to produce a positive x, which is what I needed over here on the left. And I'm going to divide the 25 by a -5, which will produce the -5 that I desired also. So now I have a common binomial factor. And we take my common binomial factor and factor it out, x minus 5. And then the Left over will be the result of dividing my GCF, this common binomial factor, divide this by x minus 5, and I'm left over with 2x. Divide the second one by x minus 5, and I'm just left with a negative 5 result. So now this quadratic part, this quadratic factor, is now further factored to be x minus 5 times 2x minus 5. This x plus 2 should still be out in front if I wanted my fully factored form. So x plus 2 times those two is f of x, rewritten in fully factored form. Now, all that work allows me to do what I was trying to do, set out to do from the beginning, is to find all the zeros. So I have x plus 2. I'm supposed to set that equal to 0. I have x minus 5. Set that equal to 0, and set 2x minus 5 equal to 0. So each one of my factors set equal to 0 and solve. I already had this x plus 2 result. It was x equals negative 2. That was one that was given to me. I have now x equals 5 if I add 5 to both sides. And then I get this one. I add 5, which gives me 2x equals 5. And then I divide by 2 for both sides to get x equals 5 halves. So my three solutions, my three x-intercepts, my three zeros for this function are negative 2, positive 5, and 5 halves. So negative 2, 5, and 5 halves are the solution set. Later we'll learn how to graph a rough sketch of this polynomial. If I just plot these in order, negative 2, 5 halves, and 5, not to scale, of course, knowing that this is a positive a value, odd degree function, I'm going to have a end behavior that goes down there, end behavior that goes up here, and I'm just going to learn to connect those arrows through the x-intercepts and get a rough sketch of this cubic polynomial.